So last time we did some examples of Fourier series of a function from negative pi to pi. Today I want to show you how to do this for arbitrary symmetric intervals from negative L to L. And just to compare the differences between the two versions, I put the formula side by side. And the first thing I want you to notice is that if you look at this formula and put L as pi, if L is equal to pi, then these two are the same thing. If L is pi, that just means negative pi to pi. So you better be getting the same formula. And indeed, if you replace this L by pi, pi and pi will cancel, which will give you cosine and x, and cosine and x exactly the same. It will be negative pi to pi, 1 over pi. Again, exactly the same. So you see that the two formulas will be identical when L is equal to pi. But I still want to take some time to explain what this does. So let's think about the following. If we have sine of x, the graph looks like this. Now, what would happen if you drew the graph of sine pi x? What does this pi do to the graph?
Makes it skinny?
Huh?
Squishes it?
It squishes it by pi, right? So before, I should have said it here, this is negative pi, and this is pi. And then putting a pi there squishes it so that the height is still the same, but does this. So that this is now from negative 1 to 1. And then if you do sine of pi x divided by 3, what would happen then?
No longer that's a bigger.
You take this green thing and you're elongating it by 3, right? So the resulting graph will now be a sine curve that's from negative 3 to positive 3, like that. That's what you're going to get. And you see that the result of multiplying by pi and dividing by 3 essentially switches a sine graph which is adapted to this interval. I say the word adapted because this completes its one period in this interval negative pi to pi. But this function, it completes its one period inside negative 3 to 3. Okay. So see how going from here to there by multiplying by pi and dividing by 3 makes the function become adapted to this interval, right? And then if you put additional numbers in front of it, say you put like 2 here, then you, instead of having just one period, you're going to have like one period here, but there will be another one of these. So you have 1 and 2 period inside this negative 3 to 3, and then you put 3 and 4, and you get more and more periods, right? And all of these functions that look like sine of n pi x over 3 will be a function that's whose periods, some multiple of their periods are inside negative 3 to 3. And that's important because if you are trying to integrate two functions of these forms, sine n pi over 3x with sine n pi x over 3x, then when n and m are different and you integrate from negative 3 to 3, you're going to get 0. And I I explained that this is what we call orthogonality relations, right? And if n and m are equal, then you can do this calculation by changing this into a sum of two cosine functions, or difference of two cosine functions. And after some calculation, you'll see that this is going to give you 3, because this is 3. And all this works because these sine functions, they complete their periods inside the given interval. If you have, say, sine of, instead of like 2 pi x, if you put like 1.5 pi over 3, then this one will not complete its full period inside the interval -3 to 3. And what happens is that if you multiply this to any other ones with integers, you can't guarantee that's going to be 0. It might be 0 for some values, but a lot of times it won't be 0 because it doesn't complete its period. So that's basically the idea. The reason that you multiply by pi and divide by L is so that you get these trig functions to be adapted to this new interval by stretching and compressing and then stretching. Okay? So that's where these formulas come from. All right, so hopefully after seeing that, you will be able to understand why we have this formula. And in addition, when you write down the sum of when you write f of x as a0 over 2 plus sigma of n from 1 through infinity, and then an, and then plus bn. When you put the cosine and sine here, you also have to use the same exact function that you used to multiply. Lx. So that's the form that you have to write your Fourier series. Again, when you expand the function in these periodic functions, your sinusoidal functions have to be adapted to that interval -L to L. All right, so I'm going to write this as the final result, so you'll have a chance to see it again at the end of this question. Well, let's continue on to the calculation. So how do you actually solve this? Well, for any questions of these type, we decide to always start with A0, because A0 is a different type of formula, although we still use this formula. This single formula actually turns into two different flavors when n is 0 and when n is not 0, because when n is 0, cosine 0 just gives you 1. Oh, actually, I'm pointing to this one. When n is 0, cosine 0 gives you 1. So you have to use this formula. What should be our value of L? 3, because that's -L to L, right? So we put 1 over 3 integral from -3 to 3 of x squared minus 2x, because that's our f of x, times cosine of 0, that's just 1. And then we can use even and oddness. X squared is even, 2x is odd. So what does that help? Why does that help us? Yes?
You can get rid of the odd function?
Yeah, because you can get rid of the odd term. That one's going to be 0, and you can just double this one. So it'll be 2 over 3, integral from -3 to 3 of x squared dx. Oh, not -3 to 3. From 0 to 3. You double the integral, but you take half the interval. Okay? So that's the trick to use for even functions, right? So you use that, and then you integrate that, which gives you 1/3 x cubed, and you have to plug in 3 and 0. So what's that? 27 over 9. That's 3. 3 times 2 is 6, so you're going to get 6 as the interval. Okay, now let's continue with an. An is 1 over 3, integral from -3 to 3 of x squared minus 2x times cosine n pi over 3x dx. And because cosine is an even function, even times even gives you an even function, whereas odd function times even function gives you an odd function. So that part will again disappear when you integrate. That's going to give you 0 when you integrate. So the only thing that you have to calculate is 2 over 3, integration from 0 to 3, of x squared cosine n pi over 3x dx. And we do this by using the tabular plus minus d integral. You put x squared, 2x, 2, and then 0, cosine n pi over 3x. And when you integrate, the reciprocal of this coefficient of x comes in front, right? So integral of that would be 3 over n pi sine n pi over 3x. Integrate that again, that's negative 9 over n squared pi squared cosine n pi over 3x. Sorry, my handwriting is a bit small. And negative 27 of n cubed pi cubed sine n pi over 3x. And then it's plus, minus, plus, minus. And then you multiply this way, this way, this way. And the result is, let's see, you have 3x squared over n pi. Don't forget the 2 over 3. It's easy to forget that coefficient in front. So 3x squared over n pi sine n pi over 3x. Then plus 9 times 2 is 18x over n squared pi squared cosine n pi over 3. And then 2 times negative 27 is negative 54 over n cubed pi cubed sine n pi over 3. And then you have to plug in 3 and 0. Yes?
Can you re-explain why some items disappear? You said something about even.
Oh, this one. Okay, so 2x is an odd function. See, 2x is an odd function. One side goes up, the other side goes down, right? On odd function, if you integrate from negative a to a, some symmetric domain, the left-right side, one side goes up, the other side goes down, so they cancel. So it's a fact that if you integrate an odd function over a symmetric domain, it will give you 0. And another rule that we have to know is that if you have an odd function multiplied by an even function, you get an odd function. Now, if you multiply an odd number by an even number, you get an even number. It's different. I'm talking about odd function times even function gives you an odd function. Okay? And if you're ever confused, just think of an example. Odd function. What do you have? Like x cubed is an odd function, right? X to an odd power is an odd function. Even function. X squared is an even function. If you multiply, you get x to the 5th power. That's an odd function, right? Okay. So we know that if you have this one and you multiply this, these two is going to have negative 2x cosine n pi over 3. That's going to be an odd function. And I have no idea what kind of graph that it is, but I definitely know that it's going to be an odd function. So if one side goes up, the other side goes down. Integrating it from negative 3 to 3 should cancel. So that just completely goes away. It's a very convenient way of calculating. You really want to make use of it if you're given the chance. Okay. And then at this point, I want to reiterate this important identity. Where should I write it? Maybe over here. That sine n pi is equal to what? 0. Cosine n pi is equal to? Negative 1 to the nth power. Okay, so we're going to use this over here. When you plug in 3 into sine, see, 3, when you plug in here, 3 and 3 cancels, and you end up with sine n pi, right? So all the sine terms, when you plug in 3, it's going to disappear. And therefore, the only non-trivial one will be when you plug in 3 here. When you plug in 3 there, you have, oh, I forgot to put an x there. Sorry. Should be an x there. When you plug in 3, 3 cancels, and again, you get cosine n pi, which is negative 1 to the nth power. So here's what you get when you plug in 3. That's 0. This will be 18 times 3 over n squared pi squared. And then cosine of n pi is negative 1 to the nth power. And that's it. That's all you get when you plug in 3. Now, let's try to plug in 0. What sign of 0?
0.
And if you plug in 0 here, what will you get?
0.
0, because it's 0 times something. How about here? Oh, so you don't get anything when you plug in 0. And therefore, after canceling the 3, you end up with 36 over n squared pi squared times negative 1 to the nth power. Okay? Now, I want you to take some time to calculate Bn, which for this one, because sine is an odd function, this time sine times even function will be 0, because it will be odd times even. So that's going to be the odd function, and odd times odd gives you an even function. So it's really this times this that you have to calculate. Okay. So first, get rid of x squared. Ignore that. Make it as 2/3 of integration from 0 to 3. Okay. And you integrate negative 2x sine of n pi over 3x dx. Okay. Try calculating that. Yes.
So how did you get to the nth power?
The negative 1
Yeah.
to the nth power?
Yeah.
Oh, that's because I'm using this one. Cosine n pi is equal to negative 1 to the nth power. So when you plug in 3 here, 3 cancels and you end with cosine n pi, right?
Okay, yeah.
That's how you get the nth.
And your length is your distance from L, or 0, right?
When you distribute this sign.
L is, you can say that L is like the distance from the 0. Yeah. Make sure that you do this calculation.
So that'll be even. So it'll be negative 2x times sine, right? Because it's
Yes.
both even. Or
Yeah.
odd.
So x squared will go away, and it'll be negative 2x times sine. And you again do the tabular integration. Yeah, if you're still confused about even and odd functions have the property that negative comes outside, whereas even functions have the property that So if you have a function where fx is odd and g of x is even, then think about h of x, a function of odd times function, even function. Then h of negative x would be equals to f of negative x times g of negative x. F of x being odd, this negative comes outside, whereas g of negative x, well, because it's even, it consumes the negative. So you end up with this, which is same as negative of h of x, right? So that's how you can actually prove that any odd function times even function will give you an odd function. You can do the same thing. So if one side was odd, if both were odd, then both of the negatives will pull outside, which will give you positive. So you end up with an even function.
Yeah.
maybe I should reiterate that if f of x is an odd function, then integration from negative a to a of f of x gives you 0, whereas if f of x is an even function, the integration from negative a to a of f of x dx is the same thing as twice of integration of f of x dx, integrate from 0 to a.
If it's an odd
Okay, let me erase these and just write down the results.
I still have my seat.
Cosine. That would be 0. So this would be
Okay, who needs help? N is N. N is N. You just replace X by the values of the puzzle. There we got the result. Oh, really? Okay. I guess I'm remembering something else. Maybe that's.
so when you get
Oh, okay, it looks like he's got the same answer. So maybe that's right.
this
Make sure you try this.
That's all right.
First of all, that's just the
Yeah, I mean, you've got to start scheduling.
all the data. They are only
Yeah, so I got a question for you. For C1, I got 6. Alright. Yeah, so the reason why the C1 and C2 is not here. So I just
that's not even
what about C2? Yeah, but you're looking for, you're using a pre-fixed thing, so it will always be 0. Right? I was just confused about C.
Oh, but it's times 0.
No,
Yeah, this is 6 times 0. Yeah.
I didn't answer all parts of it because it's just some
oh no, okay, this was easy. So this is I didn't do it for damped, underdamped, below 0, critically damped, 0.
That's what you get.
Next 3 weeks and plug it in. I'm telling you, see how
We're trying to find 2. But I think you won't have a C0.
So it says
They make you know, C1 is 6 because X is 0.
I don't know if that's correct.
I think you forgot 2/3.
Oh, I did? Oh, yeah, I did. Yeah.
Okay, so
well, actually, the median
We're already too deep.
I don't know what line job I'm going to say that.
okay, so this is what you have to. Yes.
Should that be negative on the second integral one? -3 over n pi?
Yeah, integral of sine is negative cosine, right?
Oh.
Okay, now, so we use this tabular integration and you do this times this, so negative negative is positive. So you're going to get 2/3. Don't forget this 2/3. A lot of times you're going to forget that. So you have 6x over n pi cosine n pi over 3. And then negative times negative times negative, that's negative, and 2 times 9 is 18, so it should be negative 18 over n squared pi squared times sine n pi over 3x. And you're plugging in 3 and 0. And now, again, the sine terms are not going to produce anything when you plug in 3 or 0 because of this fact that sine and pi is 0. The only non-trivial thing that you produce here will be when you plug in 3 here. If you plug in 0 because of this x here, it's not going to produce anything. So the only non-trivial one is when 3 goes in here, producing cosine n pi, which is negative 1 to the nth power. 6 divided by 3 would be 2 times 2 times, and then x is 3, so that's 12 over n pi, negative 1 to the nth power.
so they won't round.
So that's Bn. Okay, is that the answer? No, not yet. Why?
One more step.
Because you have to write down the final answer, right? The final answer is 6 over 2 plus sigma n equals to 1 through infinity of an is 36 over n squared pi squared of -1 cosine n pi over 3x plus 12 over n pi of -1 to the nth power sine n pi over 3x.
How did you get the 12? The 12 over n. I know the n pi and -1.
When you have when you plug in 3
Oh.
cancels. 2 times 6 is 12.
Okay.
Yeah. Yes.
Where did you get -1 to the nth power?
Here, cosine n pi is -1 to the nth power.
Okay.
If 3 goes here, when 3 is plugged in, 3 and 3 cancels and you get cosine n pi, right? Which is -1 to the nth power.
So why does sine cancel out when it's 3?
When you plug in 3 into x, 3 cancels and you get sine of n pi.
And that's just equal to 0.
That's equal to 0. Yes?
Where does the 6 over 2 come from?
The 6 over 2? Where do I have 6 over 2? Oh, this one. Oh, okay. That one. Okay. So the full Fourier series formula is f of x equal to a0 over 2 plus sigma n equals to 1 through infinity of an cosine n pi over lx plus bn sine n pi over lx. And that, unfortunately, in our version of the Fourier series, you always have to have this over 2. So that the average value of the function over negative L to L matches with the average value of this function over negative L to L, because average values of cosines and sines are zeros, so this is really the average value. Yeah, there's a discrepancy between the A0 itself. If you compare the two, you have to divide by 2. I did spend some time explaining this last time. Yeah, I think that's yeah. It's on my channel. So if you look at the one of the videos there, that I uploaded this morning, you'll see it. But I also explained that in some cases they might have a separate formula for A0 with 2 already in there. If you're using that formula, then you don't have to divide by 2 because it's already there.